Guys, so good evening once again. We're going to be continuing on transformation. Now, last week we were looking at the different types of transformation, and we were up to enlargement, and so we have about 4 to 5 types of transformation that you'll be looking at. So we have what we call translation, which is a slide. Then we have rotation, which is, as you know, it spins on an axis, more like a gig. And then you have reflection. A reflection is when you have an image with a mirror line, and the mirror line and with the object and the image, they can fold. If you fold along the mirror line, you can fold your image onto your pre-image. All right. So we looked at enlargement. All right, and we say enlargement has to do with either something getting smaller. So we generally say enlargement or reduction, because we can magnify the thing, we can make it bigger or we can make it smaller. In other words, we can zoom in or we can zoom out, all right? And so that's where we were last week. All right, so just to recap with enlargement. So in order to enlarge or reduce an object, we are multiplying the size of it. And we multiply the number that we use to multiply to make the size of it either get bigger or smaller. We call that a scale factor. And that scale factor is represented with the letter K. All right. Now, there's a given a point O and a real number K. Then A, which is the image of a point A under the transformation E, which is enlargement. If the image lies on OA and OA dash, then it is equal to KOA. So what that means? It means that if you have a line OA and you enlarge it to a line OA dash, that means you would have multiplied OA by K to get OA dash. Everybody is following this apart? You understand exactly what I'm saying? Let me just give you just a slide.
Right there.
All right, so I know we're not working with a diagram, so let me see if I can work with a diagram. All right, so let's say we have a line, and let's say that line up to that point is OA. But here we now have another line which is on the same line. But what we notice now, this line is bigger or longer than the other line. That means you have enlarged the line or you have magnified the line. So we are saying that if the original length OA, if that is your pre-image, right? And then now you go from O now to another length, which is A dash. Now A dash here will be your image, and this image would be the enlarged image. So what they are saying, in order to get the length of OA dash, you would have to multiply OA by K. So if this length is OA, and so the length of the enlargement from here to here, we would have to call that OA, but not just OA, but a number times OA, which is equal to OA dash. That's all they're saying. So the length from here to here would be OA dash. But if you have this length, which is OA, and you multiply it, say, by 3, then you will get 3 times the length of OA, and 3 times the length of OA, you would get 3 times OA would give you OA dash. That's what they're saying. If you multiply OA by some number, so if you have 3 times OA, it means that it will be this. It means that OA dash is 3 times the length of OA. So clearly OA dash would have been magnified by 3 times. All right. Now the scale factor K in some subjects such as like HSB, where you have to use a magnifying glass or a microscope to look at small objects. When you look at them, they appear larger than they really are. And so that number of times that it is bigger, we call it the magnification. So if it is 10 times bigger than what it really is, then the magnification is 10. Now, in this case, where we're just working with calculation of K, K would be the magnification just the same. All right, is that clear, guys? And how you really get the magnification is to divide A dash divided by A. Or if you want to say the length OA dash divided by the length OA will give you K, which is the magnification. So let's say that OA dash is 9. If OA dash is 9 and OA is 3, and you divide 9 by 3, then K will be equal to 3. Because 3 into 9 goes 3 times. So that will be equal to 3, which is equal to K, which tells you the amount of time the object is magnified. Or in other words, how much time bigger than the original object it really is. So it is really 3 times bigger than the original object. All right, so just in the same sense, if we can say an object is 3 times bigger than an object, or if we can say the image is 3 times bigger than the pre-image, we can also have an image which is smaller than the pre-image. That means we can have an image which appears smaller than what it really is. And in that case, we are really making the object smaller, right? I don't know if you ever watched the movie Honey, I Shrunk the Kids. That's a long time movie where this mad scientist, well, I wouldn't say mad scientist, the scientist was experimenting with some laser light and he beamed it on his kids and they become miniature, very tiny, so tiny that they were like ants. And so that would be a reduction. So you're making the object smaller than what it really is when you're doing reduction. All right. Now, what that means for K? When the value of K, which is a number that you're multiplying by, when that value of K is greater than 1, right? Because you know that if the pre-image is OA and you times it by 1, what would you get for your result?
Repeat again, sir.
If OA is the pre-image and you times it by 1, what would you get?
1 OA, sir.
Yeah, you would just get back OA. Would you get a magnification? Would you get an enlargement?
No, it would just be the same.
It would be the same, right? So what we are saying, 1 multiply OA, you are going to get back the same OA. But if you use a number greater than 1, say for instance, OA times 4. Now, any number which is greater than 1, and any number that is greater than 1, meaning if you have a number K, which is greater than 1, and you multiply your pre-image by that number, you'll get an enlargement, because this here 4 times OA will mean that you have 4 times the size, the actual size of OA. So that would be an enlargement or a magnification. Is that clear, guys?
Yes, sir.
Right. Now, if it is that we want a reduction, now we would have to have a number between 0 and 1. That means that a number between 0 and 1 would not be an integer or a whole number, but instead it would be what? It would be what kind of number? What do you call the number? What kind of number fall between 0 and 1?
Natural numbers, sir. No, so they call it.
No, not natural number. Give me a second, guys.
Real numbers.
All right, I have to try to kind of keep down my coughing with drinking some water or something, right? Now, it would, if you have a number between 0 and 1, think about it. A number smaller than 1 and greater than 0. Anybody? It can only be either a decimal or a fraction. Do you agree?
Yes, sir.
Right. It has to be a rational number, which is a fraction or a decimal. Now, what that means, it means that if you're multiplying the pre-image by a fraction, so if you multiply, say, OA times a half, would it get bigger or smaller?
Smaller, sir.
Smaller, right? So in this case, K would be a fraction. And whenever you're multiplying by a fraction, your pre-image going to be smaller. than the actual size. So in this case, we are saying that you have what we call a reduction or a contraction, right? So whether you have an enlargement or a reduction is really dependent on the value of K. So if K is a number which is greater than 1, then you're going to get an enlargement when you multiply by K. But if K is a number between 0 and 1, then you're going to get a reduction. And note that we are saying between 0 and 1 because we really don't do enlargement or reduction with negative numbers. All right. So it has to be a number between 0 and 1 for a reduction and a number greater than 1 for an enlargement. So that is very important for you to know that if K is greater than 1 and you use it as your scale factor to multiply your pre-image to get your image, then you're getting what? An enlargement. But if K is a number between 0 and 1 and you're multiplying your pre-image by that number, you will get a smaller image than the actual pre-image. So in that case, you have a reduction. So that's the idea behind enlargement and reduction. Is that clear, guys? Any question about that? All right, so with that said, let us look at this now. Now, clearly, where we have A dash, B dash, C dash, that triangle would be a bigger triangle than A, B, C, right? So clearly you would have an enlargement. Now, the enlargement is based on your scale factor. So now the triangle ABC and its image A dash, B dash, C dash, and the enlargement transformation center O and a scale factor of K equal 2. That is the image as a magnification of 2. So clearly now, if you notice here, the magnification, they take the length of this line from O to A dash and divide it by O to A. Right? That's what they do to find their magnification. Now, sometimes you can be asked to find the magnification. So once you recognize a straight line, then you would find the pre-image from O to A, right? So you would look at that length. So if let's say that they give you that this length is say, let's say they give you this length to be 2, right? And then now they give you this length to be 8. That is the overall length from here to here. Now your magnification would be OA dash divided by OA. And so we know that OA dash would be 8 and OA would be 2. And you divide 8 by 2, you would get 4. So that really means what that is saying, your magnification is 4. That implies that K is equal to 4. Is that clear, guys? Is that clear, guys? Because it means that you would multiply from OA, you would times it by 4 to get 8. Everybody is understanding? Raise your hands. All right, Miss Way, some seem to be okay, Miss Green. Miss Cabrera, notice you came a little late. Do you understand what we're doing?
Barely.
We're really looking at enlargement and reduction, and we're talking about the magnification, how we measure how the magnification of it or the scale factor. All right, so just to recap quickly what we were doing. So let me clear this and go back to the previous page. So this is what we were talking about, Ms. Cabrera. We're saying that in order for you to get an enlargement, right, your pre-image has to be multiplied by some number, which is K. Now we're saying that K is a multiplier, right? So if your pre-image is A and you multiply it by 3, OA, and you multiply it by 3, it will be 3 times the size of OA. You follow?
Yes, sir.
Right, so K would be the multiplier that enlarges the object. So we're saying that if K is a number which is greater than 1, you would, and you multiply by a number greater than 1, you will get an enlargement. But sometimes K can be a number between 0 and 1, which would be like a fraction. If you multiply by a number which is less than 1 and greater than 0, between 1 and 0, which is a fraction. So if you say half times OA, would that be an enlargement? Ms. Cabrera? If you multiply OA by a half, will you get it to be bigger than OA?
Yes, sir.
Say that again.
Yes, sir.
But think about it. If you multiply your age by a half, would your age become bigger? Ms. Cabrera?
No, not really.
No. So what we're saying, if you multiply by a fraction, it will become smaller. That's what we're saying. So if K is a number, which is a fraction, instead of getting an enlargement, you will get a reduction. The only time you get an enlargement is when K is a number greater than 1, like 2, 3, 4, 5, and so on. You following, Ms. Cabrera?
Yes, sir.
Right, so K here is what we call our scale factor. Now, what we were doing with this image drawn here, we're saying that look at these two triangles. A dash, B dash, C dash would be the image. Would it be a smaller image or a bigger image?
A small image.
So Ms. Cabrera, as I was saying, what would you say?
A smaller image, sir.
No, the one that is labeled A dash, B dash, C dash. That triangle, would it be bigger or smaller than the other one?
Bigger.
It would be bigger. So because it is bigger, obviously you would have an enlargement. Because the one that we label with the dash, that is actually the image. And the one without the dash, that is a pre-image. All right, so we are saying, suppose you get this diagram. And they give you the length from here to here to be 2, say centimeters, right? And then now from O to A dash, you get another length, say 8. Centimeter. So, Ms. Cabrera, what we were saying that you could actually find what K is based on